Hi, guys. Can you can you return? Okay, perfect. Okay. Okay, as we talk in last session, in the last session, we present the 4 layers. The first layer is the sensors. The second layer is data aggregations and gateways. The third layer is the edge. And the last one, the fourth stage, is the data center. And remember that the architecture shows how the data is processed and how the control message is processed. Okay, it's the flow of the uh, the, the, the data flow between the two layers. Okay, between the layers. So again, about the one important technology is the cloud base, okay, IoT cloud base technology. And today you have a much more than these 5 companies. However, this company is the most important. You have the Amazon, okay, the Amazon AWS service. You have the Google Cloud, okay, the GCP's servers, and you have the IBM Watson, okay, is IBM Watson is not so, you don't have you have a large amount of implementation, but it's not so common than GCP and Amazon, the Microsoft, because the price is a little expensive than the others. Okay, where is my pointer? Okay, here, the Watson. You have the Microsoft Azure is very common implementation. And the other two that you have more specifically, you have the Salesforce and the Oracle. But in the both cases more specific cloud. It's not a generic cloud like you have in the GCP, in the AWS, and the Azure. Remember, the cloud computing has the cloud computers appears to solve a big problem in the on-site computer. Before the cloud computer, if you have a service that you want to provide, you need to have a data center that need to invest in this data center. However, when we invest in the data center, you have a lot of problems. For example, the first problem is in the specific period, you need to upgrade your computers, your servers, because the technology is, if you have the technology, the technology change and require more research. And you need, for example, you spend $1 million in a data center, in 5 years, you need to reinvest this amount of money. The second thing is you need to have a very high level professionals to maintain these clouds. Oh, sorry, the on-site, these data centers, okay, on-site data centers. Because, for example, if you use the cloud, if you use your data center, you need to provide, you need to have guys to pass cabling, okay, pass cabling to provide the connections. You need to have guys to configure the servers, to configure the routings, any other type of requirements that you have to provide service, okay? And again, you need to provide security, for example, and all of these features requires a very high level guys or very prepared guys, okay? So uh, to support this change, in particular the cost of the infrastructure, the idea of the cloud computers appears. In the beginning, only you have one place in the internet that has all of this service. You provide machines that you rent these machines and install your service there, okay? And you don't need to worry about the security because the cloud provides security. You don't need to have the guys that provide the routing because you have this guy in the cloud service. But again, in the beginning, you have a few, you only avoid to have the data center. You move everything to the cloud. But the cloud computing evolved and you become to have more than it. For example, if you develop one application, if you use one application, without you install the application in your computer, you can use the service from the cloud. For example, the Microsoft 365. Okay, the Microsoft 365 or the Google Docs is an example of the cloud application. In this case, you don't need to install the application in your computer, but you use an application in the cloud. And you don't need to think about the update because the service provider, the office provider, worry about the update and keep the application updated and keep the application secured. And if you need to create a new feature, you don't need to send updates to the user, install the new feature. It's more easy to control the version that your user has, okay? And use the cloud computer, the second level of the cloud computer support and to avoid to install things. For example, again, I told about the Office 365, I told about the Google Docs, but you have others. For example, a Jira. Jira is an example of application in cloud. The next level of the cloud is to support the development. Think, for example, that you need to generate an application, and this application you need to implement and to install a lot of machine learning service. Machine learning is a type of technology that spend a lot of processors and memory. Okay, you need space and need processor. Okay, and another thing is it's very hard to develop the algorithms. Okay, to turn the algorithm, to train the machines. Again, things that you have a place in the cloud that provide this thing done, ready to you. Okay, and the next level of the cloud computing, you consume not only define application, but you consume service. For example, authentication service. Okay, you don't need to think about how to configure the authentication. You can use a very advanced authentication model from the cloud. Okay, like a service, you only need to connect your application with the service provider. Finally, the last level of the cloud computing is not so common. You have a few implementation. It's very specific implementation that you use, where it is when you move the desktop to the cloud. Okay. Again, it's you use this type of implementation in a very few cases. I remember one implementation, one project that I worked. The project is to implement a very secured installation, and we don't use the web cloud or the public cloud to provide this type of technology. Okay, I use a private one from the Air Force, and you have in the cloud desktop. Okay, you didn't install the desktop in the client. You use every time that you use the client, start the computer, you go to the cloud and you copy the cloud desktop to the desktop and use the cloud desktop. Okay, again, this type of technology is not so useful. It's not so common. Requires a very powerful connections, but it's the new. You have a lot of advantage to use this type of technology. To provide the cloud computing, the most important technology is the virtualization. What is the virtualization? The virtualization is things that you, for example, you have your computer, okay? You have your hardware. Above your hardware, you have an operating system. Above your operating system, you have a group of applications. But again, things that is possible to have in the same hardware, you have different machines running individually, okay? Running complete, isolated one to other. It's what virtualization provides. For example, you have the same machine, okay? The same hardware running one operation system, and you have one guy like hypervision, okay? What is the hypervision? It's a different layer of the operation system that provide some, the hypervision, it's like it provides connections or libraries like the hardware provides, okay? What the hypervision does is it masquerades the operating system and provides service directly to the, not directly, but like directly to the hardware. And above this guy, you install different systems, okay? Why this technology is so important? Because things in data center, and things that you move your data center to the cloud, and things you have one server, physical servers for each client. It's not work. What happens now is a little different. You have a big hardware in the data center, and you sell, for example, small machines. It's the case. If you already have the opportunity to work in the cloud of Microsoft, then when you create a hardware, you define the size of the hardware. You define the amount of memory, the type of memory. You define the amount of type of processor, and what you do, you use a virtual system that get this information, that divide the hardware, the capability of the hardware in the small part, okay? Create different machines. Another thing that I missed to talk is about the cloud is in the cloud, you never know if you don't pay for it. In some cases, you can pay, okay? But you really never know where your data is. For example, you go to the Amazon and create a machine in the cloud of Amazon. And you define, okay, my machine is in São Paulo. Yes, it is in São Paulo. Which place of São Paulo? The Google has a lot, more than one data center in São Paulo. You never know, but it's in São Paulo. It's not in New York, okay? Again, there is some SLA or some contracts that you can do, for example, to Amazon, Microsoft, and others, that you can define, okay, I want my data only transfer between server 1, 2, and 3, okay? It's what happens, for example, in US with defense, okay? You use not exactly the same cloud that you use in the Amazon, but the specific about the defense network in the cloud, the defense network in the cloud, and the defense network knows exactly when the data is, okay? Because you have a SLA and the contracts, and you pay more for it, okay? So, again, back to here. The virtualization is the key technology to provide a cloud computing, okay? Any questions? Do you already using the virtual machines before? Yes or no? Some application like virtual is what's the name? Is VMware, Citrix, or I believe it's VirtualBox. Is a very common because it's free. Did you already use it? One of these technology before? Who already used it? Nobody?
I don't think so.
Okay. Okay, now we studied about the cloud-based service models. I already talked about which one of them, okay? And it's very important because when you start to for example, if you plan to use a cloud to deploy in one system in the future, not about our project. Okay, in the last session, I received a question about why you don't use I don't know, Google GCP, Google, or Microsoft Azure or AWS in the Amazon. And we use a different architecture in the final project. The reason for it is because when you use this type of service in the cloud, you need to put a credit card. Okay, you need to set a credit card. Without a credit card, you cannot use this type of technology. Again, for example, Microsoft provide, I don't know exactly how the amount of data to use in his cloud for a year. It's a lot. It's not a few, it's a lot. However, to avoid problems, Microsoft asks you to set your credit card. Because if you did some bad things configure wrong your environment and install things that you or consume more than it's free, and the Microsoft can charge you. Okay, it's the reason that we didn't use in the final project this type of technology, because if one group nobody has credit card, you cannot do the work. It's the reason. It's the reason to use a more simplistic example to implement the service in the final project. However, in our class, I will show how to do the things in the common, in the open, outside the cloud, okay? You install your own cloud in your computer. I will show how to do it. However, I will provide the same example in the cloud. And if you have credit card, you can reply the exercise in the real cloud. If you don't have a credit card, you cannot do, but you have the class example without have the cloud server. Okay. It's the reason that you don't use I believe if you can use the Google, for example, you can create a more powerful example. However, the problem is the credit card. When you go to the Google or Microsoft and others, and the first thing that you need to understand is what is IaaS, PaaS, SaaS, and in some cases DaaS. Okay, IaaS is the infrastructure as a service. In this model, you rent computers. Okay, you completely rent computers. Okay, for example, you enter in the Azure and define, okay, I want to have a service with this processor, with this amount of memory and this amount of storage. And the Amazon will create one virtual service like you define to you. Okay, it's the IaaS. And the PaaS is a little different. It's like the Google Docs works. You have a service in the cloud, okay? You have a platform in the cloud, complete platform. It's not only one library. No, you have a complete platform in the cloud. And you use this platform without need to install in your computer. It's like the Office 365 and the Google Docs. And this SaaS is software as service. You have a service in the cloud, like, for example, authentication, like a firewall, like, I don't know, like graphical card processing and others, okay? Machine learning services, like, for example, the IBM cloud has a lot of cognitive service. The people that use the IBM is because want to use its servers. There a lot of service that it has to provide cognitive. Okay. In this case, you use the system. And the last one is the desktop. I will now explain which one of them. Okay, the first is the infrastructure. Again, you deliver computer infrastructure on outsourced basis. Okay, again, you buy to use a virtual service in another place. Okay, Amazon provides you a service in one place in your cloud to you. And you don't need to worry about the availability. You don't need to worry about security. The basic security, okay, we will need to worry about security, but the basic security, no. You need to configure, you can pay for more advanced security service, but the basic one, you don't need to worry. You don't need to worry about the update of the firmware, okay? You only need to get your computer installed, and you think only about the operation system to up. You don't need to think about the hardware, okay? The platform as service provide a platform allow customer to develop, run, and manage application. And here it's very good to understand. Okay, it's the one site. When you have one site, you're responsible to manage all layers of the networking. When you have IaaS, you start to worry about above the operation system. But the virtualization, the self-storage network is you don't need to worry. And the PaaS, you think only about the data and the application, and the SaaS, you don't think nothing. You only use the service. Examples. IaaS, you like OpenStack, Open Virtual Networking, KVM, okay? You pay for virtual machine, for network storage and containers directly. The PaaS, for example, you have the GitHub, the GitLab, the Kubernetes, and Docker. And the SaaS, you have the cloud scripting, Verizon, and other services, like, for example, the Jira. Jira is here, okay? Finally, you have the desktop as a service. Again, you have your desktop is not in your computer, your desktop in the cloud. The good thing is you can share data between different devices. For example, a smartphone, you can use your smartphone to access your virtual desktop. You can use your notebook to access your virtual desktop. The data and the application that you have in the smartphone or in the computer is the same, okay? It's the things that is good. You can find today in the Amazon workspace, the VMware, the Horizon, or the Microsoft Azure Windows Virtual Desktop. Again, this type of application is not so common, okay? It's you have a very few examples of implementation that you use this type of technology. Any question, guys? I think no. The silence, I suppose then the silence is, okay, everything is good. It's not the opposite. Okay, to finalize this session, it's a very important because you are applying the lab 2. We talk about one example of IoT architecture, okay? It is in the smart home. What is a smart home? I don't know, in Mexico, in Brazil, it's not so common, but a smart home is the use of IoT device to automate the functionality or how the house works. For example, you connect, for example, the coffee making machine, connect the air conditioner, the lights, the TV, and other device. Okay. For example, you can have fog detector, carbon detectors, and others inside. And the main idea of the smart house is to provide security, safety, provide security, provide comfortable, okay? And it provides this service when most of the time connect this device with a cloud application. And in a cloud application, you aggregate this data and fuse this data, generate intelligence like, for example, turn on, turn off, open door, close door, something like that. A very common example of for example, in the US, again, it's not so common to have a very automated automated house. But most of the time you have the security appliance. For example, you have a lot of cameras that record images from your house, inside your house, and outside your house. And if this camera detects somewhere hazard, the camera can send the image to you. Okay, you receive a pop-up in your cell phone and say, okay, something happens in your house, and you click and open the camera and you can follow the situation. The system can call the police immediately. For example, detect that one guy opened one door, broken one door, or broken one car, and you call directly the police. The camera can, you can generate a pop-up in the smartphone. The camera can turn on, turn off the lights, for example. If you have people close to the main door, you turn on the light to record better who you pass, and other things. Okay, the sky is the limit. Okay, you can do a lot of different things. But this type of application is very common in West. I use this type of application when I live in West. I have a camera and that records everything outside my house. If I have some strange situation, like one guy is close to my main door or is close to my car, you generate an alert. In some case, depending on the situation, you generate a noise, a sound, okay, like an alarm. There are a lot of times that is not nothing. Is most of the time is only a beer close to my car, okay, but it's not a bad guy. It's only a big animal close to my car, okay. So there are a lot of different type of device that you can install in a smart home. The first one is the smart lock. The smart lock is, again, it's not so common in Brazil. I really don't like this technology because fix this situation. You lost the pass key, or the system is crazy. You don't enter in your house or don't leave your house. I really don't think it's a good idea. But I have a few friends that has this type of it has this type of technology in your house in Brazil, okay? And there are some smart lockers that implement a very powerful authentication protocol, very advanced. Okay, it's very secure. Okay, it's not only check you have cameras installed to check your face to detect, and make a double check with the finger, or make double check with the passcode. Okay, and you can use it, for example, with dog sitters. For example, I know one guy that has not in the main door to enter in the house, but to enter in the garden, okay, and to have access to the dogs. Okay, when this guy leave or to travel to a holiday or to work, when he travel, the dog sitter can enter in the house, in the home, to put food to the dogs and to play with the dogs. It's much better than to give the key to this guy. It's a very useful and a very amazing way to provide access to your house. Okay. The second one is more common, is the climate control. It's common in the West, but it's not so common in Brazil, because the Brazilian house is not climated. Okay, in US, all the houses climated. You have the same temperature in the summer or in the winter. Okay, and you have this type of device. This type of device perform two tasks. The first is control the humidity and the temperature. Okay, again, in US, the house you have the house is climated, and what it means? It means that you define one temperature to winter or to summer. Inside your houses, you have the same temperature. Is all the time is comfortable. Okay, it depends if you have 47 Celsius degree outside or minus 20 degrees Celsius. It's no matter. In your house, you keep around 20 Celsius degree. Okay, but this device has another functionality. You can configure this device, for example, to economic. What it means? We try to keep the temperature in the temperature that you define. However, the way that it does it using more advanced algorithms. Okay, you have a very smart intelligence to compensate, for example, to turn off the air conditioner, not only when you acquire the temperature. Okay, you turn off before, and it's to know again before the temperature is decreased to the point that you want. Okay, you have a very smart algorithms inside to manage the temperature and the humidity. Another one's the light. Light is not make sense without my kids that like to see the blue lights, red lights, would like to control the lights in his home. But the light is very important things to, for example, to safety and security. Okay, you can leave. I have this technology in the US. You leave to your house. You travel, for example, to Brazil, and you're programming the lights to work, and not only the lights, but the lights and the field the appliance in your home to work like if you stay in the home. For example, if you course, if you it's common to open to turn on the lights 7 p.m. and turn off when you go to sleep 11 p.m. Your house works like that. Okay, you turn on 7 p.m. and finish and turn off 11 p.m. like if you in the house. Okay. About security system, I already told. The another one is a smart motion sensors. Most of the time is connect with the security system. One of them is not so common in Brazil. You have a few services that a few companies that provide this service, for example, to cars and to house. The system is monitoring from external, a third-party company, and the third-party company that identify when you need to reply to refill filters or to make some maintenance in the system. Okay, it's one other example. Any question, guys? Anything that you want to talk to ask? Yes or no?
No.
Okay, you are very calm, very quiet. Did you really understand what I explained, or you are tired?
Tired of the week.
Yeah. Okay. We are close to finish, and you have opportunity to exercise this concept. Okay. Where is it? Okay. In the first part of the session, we discuss about the IoT architecture. Okay. Again, it's you have a lot of concept, but it's not so hard. Okay. the important thing about the last part, the first part of the class is, okay, you have the 4-layer architectures that define the data flow and the control flow, okay? The first layer is the sensing, the second one is gateway and the data acquisition, the third is edge, and finally you have the cloud. You have a different type of implementation of the cloud, okay? EAS, SAS, and PAS, and DAS. And finally, I show the smart home. And in the few minutes after the next break, you realize one exercise in the Cisco Pack Tracer to implement a smart house from scratch, okay? But before you realize this exercise, I just only show a few comments. It's a very short, it's only 10 slides, okay? About the smart objects. It's only 10 slides, not because it's not so important, because you work with this top if your other professor, Professor Yates, okay? It's the reason that you don't go so deep. I just only explain in the general perspective. So, I missed one thing here. I need to reshare again. Okay, so this unit is the aims to introduce the different type of IoT objects and its properties. Okay, the first topic is what is a smart object? Before explain what is not smart object, the smart object is the object that enhances the interaction. Okay, interaction is the key word with a smart object and the other smart objects or the people. Okay, if device does not have this capability, it's not smart. A smart object is compounded by sensors and actuators. Okay, that is no smart object. Okay, so what is a sensor? A sensor is any electronic device composed by sensitive cells that is able to measure things. Okay, physical things. Okay, light, temperature, the proximity, images, light, gas, humidity, pressures, and acoustics, and others, okay? Another no smart object is the actuator. Actuator is hardware that responds to moving or controlling a mechanism or system. For example, open a valve, turn on, turn off hands of one machine, okay? It's what is an actuator, okay? The smart sensors is sensors that has the both, okay? You have sensors and actuators. In some cases, you have one sensors. In another case, you have both. To understand what is smart and not smart, this picture here is very amazing. Smart object, you have interactions, okay? Interaction with other smart objects and interact with people. Not smart objects does not interact, okay? Those smart objects, you have sensors and actuators. Smart objects, you can use smartphone, microcontroller, robots, and microcomputers. So it's very important. You have a large number of IoT devices. A smartphone can be an IoT device. But when you think in academic part, most of the time you study or Arduino or Raspberry, okay? And there are differences between Arduino and Raspberry. Arduino is only a microcontroller. Raspberry is a small single board computer. There are advantages and problems to have one of the or other. For example, the microcontrollers does not have operating system. And most of the time you need to control directly the gate and directly the sensor. In the Raspberry Pi, you can use the Raspberry OS that is a type of a version of Debian. It's a Debian customized to Raspberry Pi. Okay. If you have a Debian, you have the same functionality that the Debian has. For example, the Raspberry already has support Wi-Fi. The card has Wi-Fi. This card most of the time has Bluetooth connections. For example, you need to have, it's a good thing. You don't need to install and programming a Wi-Fi like an Arduino, okay? But you have more power. Raspberry has more power than Arduino. But in some cases, you don't need a lot of power. You need to only to control, for example, an actuator, a mechanical actuator. It's the reason that you have one Arduino of some kinds. You don't need to use a Raspberry that is much more expensive than Arduino to control, for example, to open or close a valve. Okay, maybe Arduino is enough. Okay. In our project, we use the Raspberry Pi and an ultra sensor. And the idea is, if you see here, the top of the can, you install this combination, the Arduino, the Raspberry and the sensor. And when you close the sensor, you measure the distance between the first object to it. Okay. If you define, for example, if you have an object or trash here, the sound thought and return, and you measure the distance between one and of them. Okay, it's what the ultrasonic sensor does. Okay, if the position is here, so if the trash is here, you send a sound here. It's hit with the object, tackle, and return, and you measure the distance. It's the way that the Raspberry does, the ultrasonic works. Why you don't use the Arduino in this implementation? Because you don't need to do a lot of things. You don't use Arduino for two reasons. Raspberry is much more easy to configure into programming. Okay, it's very easy to work here. And on the other side, you have Raspberry is much easier than Arduino. Okay. The other thing is the school has a considerable number of the Raspberry device. Okay. And because our course is very short, the idea is to use Raspberry to become easy to implement the final implementation. But you can use the Raspberry too. Sorry, the Arduino too. Okay. One question to you. Did you already see the message that Jose Maria sent, I believe yesterday or 2 days ago, about the Raspberry device that is available to use? Did you check this message or not?
Yes.
Yes.
Okay. Okay. Perfect. So I have a video here. In this video, you show the same implementation that you use in your physical implementation. Okay. It is. Oops. Okay, just only a few examples, very short, to see the idea. The device implementation is something like that. Okay, in this example, you use only the one ledge only to detect the trash is full or empty. Okay, just only to do it. Okay, and you use the one ledge. You can use three. It's optional. You think and define how you finalize this implementation. Okay, Any question, guys?
Not sure.
Okay. Okay, now I will give another break, okay? And after this break, we return, I will explain a little, I will make a short explanation about the oral exam and the argumentative exam, okay? As I promised in our meeting class. And after each, I will give you time to work in the, oh my gosh, in the lab, okay? Now is, I don't know, I believe it's 10:54 and we return 04, okay? See you soon, guys.